All right, so we have the bookinfo application deployed in both cluster 1 and cluster 2. And right now we access the Ingress Gateway of cluster 1 and we get the product page running on cluster 1. And we did this by creating a virtual gateway and a route table to expose the application. So what we're going to do next is update this virtual gateway so that it selects both Ingress gateways across both the clusters. So it will select the Ingress gateway on cluster 1 and it will select the Ingress gateway on cluster 2. And then what we're also going to define what we call a virtual destination. This is a way to group together multiple services that are running across multiple clusters. And we can give it an arbitrary host name, called productpage.global, which is going to be composed of product page services that are running in the bookinfo front-end namespace in any cluster, because we didn't specify any cluster name here. So when we create this virtual destination, and I can go into the Gloo platform UI, and we can see the details of the virtual destination. And you can see that it's discovered these two services, product page on cluster 1 and then product page on cluster 2. And what we'll do next is update the route table, and instead of going to the cluster 1 directly, we're just going to route to this new virtual destination that we just created. So once I apply this, and I go back to my browser, and if I hit the Ingress Gateway on cluster 1, I will get a round robin between product page on cluster 1 and then product page on cluster 2. Because I'm round robining between the two, because that's just the default behavior. The other thing we can do is I can access these applications to the Ingress Gateway on cluster 2. And because I created the virtual gateway to listen on both, I can go to Ingress Gateway on cluster 1 or cluster 2. And again, if I go to cluster 2, I'll bounce back between product page on cluster 1 and product page on cluster 2. So we can also see this behavior in the Gloo platform UI. If we look at this graph, you can see all of the various services. We can change this to show it by group by cluster. So right now we see the different services and the different traffic that's flowing between these services. So we can see Ingress Gateway of cluster 1 sending traffic to product page on cluster 1, on the bookinfo front-end namespace on cluster 1, and we can then see product page talking to reviews, and then details, and reviews talking to ratings, and so on. And we can now also see the second cluster. We can see the Ingress Gateway on the second cluster, and then talking to the product page on second cluster, and so on. So we can really see the full picture of what's going on and see how traffic is flowing between all of your services. So again, we're picked the round robin default behavior, but this might not be what you really expected. You might want the traffic to always go to maybe the local cluster first, and then you can easily do that by defining an extra policy called a failover policy and an outlier detection policy. Again, we can attach these policies to routes based on labels. So we're going to apply the failover policy to the virtual destination using this label. We didn't put the label yet, so we'll have to update the virtual destination. And we can say that we want to use locality to define the failover. So by default, it will try to find the local service first. And if it cannot find one, then it will try to find one in the same zone. And if it can't find it there, it'll do next region and so on. We can also be more explicit and say, maybe you will have one cluster in US East and one in US West and one in Europe. Then you can say, if US East is not responding, you want to go to US West first before you want to go to Europe, for example. So you can be very fine-grained here, and you can also, and we'll also define when you want to fail over. And you can do that using an outlier detection policy, where you can say, when I have 2 errors in an interval of 5 seconds, I want to fail over for 30 seconds, and then I want to try again. And if it's not fixed yet, then fail over and so on. So let's create these policies. And then after it's done, I can just update my virtual destination to add that missing failover equals to true label. So now the 2 policies that I've just created get automatically attached to this virtual destination. So now if I go back to my browser and hit refresh over and over, I will always get the product page on cluster 1 because I'm going to the Ingress Gateway on cluster 1. If I change this to the Ingress Gateway on cluster 2, I will always get the product page that's running on cluster 2. So if we look at this diagram flow, this kind of represents what we're seeing right now. If you go to Ingress Gateway on cluster 1, you will get to the product page on cluster 1. Everything we've applied here, we did it to the gateway, but it also applies for east-west services. So anybody in Mesh can call productpage.global and they'll get the same multi-cluster failover behavior that we've seen in the gateway. So let's do some tests. So imagine if we scale the product page on first cluster to simulate a failure. So we'll run this patch command so that so it's not running on cluster 1. So we're just scaling it down to 0. So now, as you would expect, we'd want the Ingress Gateway to center product page on cluster 2. So let's go to the Ingress Gateway on the first cluster, but you'll see that I'm actually getting response from product page from cluster 2. So that's one use case. That's mobility. We can decide where the service I want to run. If I want to move a service from one cluster to another cluster, I can go ahead and do it. Previously, without this functionality, if I moved a service from one cluster to another, I'd have to inform the consumers the new address to route request to. But with virtual destination, I don't need to do that at all. It's going to be automatic. It doesn't impact the consumer, and the producer can decide when to move a service and where they want to move it from one Kubernetes cluster to another, to a different platform, a different cloud. It really opens up a lot of different use cases because it's very flexible. So now let's go back and fix the application so that it's running again on cluster 1. And if I go back and refresh in a few seconds, traffic should be going back to cluster 1 again. So let's see something different. This time the service is running, but it's not going to respond. It's that the outlier detection policy, right? So we've configured it so that it automatically fail over if it hits a certain number of errors. So again, to simulate this, we have this basically we have this like patch command so that it's not going to respond anymore. So we want it to still be running, but just not respond anymore. So let's try this. Maybe give it a few seconds. No, looks like it's still running. Maybe I did something wrong here. So let me see if we did this correctly. No, I see the error message. Yeah, I think we did it too quickly. Let's go back and do this a little bit slower. Let's go back and run the patch command again. And actually wait for the deployment to come up. Okay, now we should be good. So now if I hit refresh, you can see now I'm going to cluster 2, right? So even though product page is cluster 1, it's running in cluster 1, it's not responding well. And it's doing this because I have a policy. By default, I'm retrying 3 times. Istio retries 3 times. And the failover policy will kick it out after just 2. So the first request fails. Istio will retry 2 more times. That hits the 3 limit. And then it just gets bounced to cluster 2. As a user, I'm totally not even impacted by this outage. So now let's activate product page on cluster 1 again, and after about 30 seconds it should go back and we should be able to hit cluster 1 again. Oh, there it goes. We've hit the 30-second limit. Yep. So yeah, very powerful. The key is that this architecture is superior to upstream Istio's multi-cluster. In upstream Istio multi-cluster, you need to give the secrets to every control plane to be able to access the Kubernetes API server of all of the other clusters. This is not ideal. And just in terms of scalability, you can see that with just 4 clusters, the number of communications that are involved. But it's also not very secure because if one of the clusters is compromised, they can access the other cluster. But with Gloo Mesh, we use this agent that discovers the services, and it's passing the information to the management plane, which is going to tell the management plane is going to tell the agent what objects to create and to make the configuration to your desired setting. In our multi-cluster cross-cluster case, Gloo will create multiple Istio objects for you automatically. One of them is a service entry. So you can see the service entry for our virtual destination product.global. It created the service entry. It's going to first validate that the service that responds is really the product page service and not another service. And it's going to do that. And it's also going to select either the local workloads using this app product page. So that's why we're seeing this like round robin between the first on the cluster 1, the local service, and then the remote cluster. The local service is selected here by this workload selector, and it also selects a workload entry that is created for you automatically for the remote cluster. So you can see that it has the same label. So if I look at the workload entry and look at the IP address of that, and you'll see this matches the IP address of the East-West Gateway Cluster 2. So if I look at Cluster 2 and look at the Ingress Gateway, the East-West Gateway, you'll see that the IP address matches. On Cluster 2, it'll also create a gateway object. Essentially, Gloo will create all of these Istio resources. Gloo will create all these Istio resources for you automatically, so that compared to upstream Istio, you see exactly what's going on. It creates a lot of operational overhead for you. It solves those challenges. You just create rules on which service you want to create and expose them to multiple clusters, and you can see that Gloo has done the overhead of creating all the lower level Istio resources for you.